Today we want to do differentiation using quotient rule. So we have this equation here. We have 5x squared minus 3 divided by x minus 2. We want to get the derivative of that. So if you want to do this is how we do it. 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 So we basically need to remember quotient rule. Derivative quotient rule. So we recall quotient rule. So using derivative rule for quotient for any two differentiable functions, the derivative of the quotient of the two functions is the denominator. Note that denominator times the derivative of the numerator minus numerator times the derivative of the denominator. Okay, all that divided by the denominator squared. So this is where we need to put emphasis on. To get the quotient, the derivative quotient for this one, the rule states that the denominator times the derivative of the numerator, then minus the numerator times the derivative of the denominator. Then all that is divided by the denominator squared. That's the key thing to note. So if we apply that in our equation here, this is what we get. That's what we get. So that if we do the derivative of the polynomial we get the derivative of a constant term, remember, is 0. You have to remember that. And the derivative of a constant coefficient derivative of xn, we get that particular general solution. So applying that to our equation, we get this. So now after here, it becomes normal maths. Collect like terms together. So we do the arithmetic. Okay. Grouping. Expand is distributive property. Here we go. Then we multiply. To multiply the powers of the same base, remember, we normally hand them behind the exponents. So we hand the exponents, and in the exponents we come up with this kind of result. Okay, so do the arithmetic. We have this. Remember, we can open the brackets. So we remove unnecessary parentheses. So we see that translates to this. We combine like terms together. And when we combine like terms together, we can subtract 5 from 10. And we are getting this. Now remember, n term t power or exponent 1, get t. Remember that. So that's the case there. Again, for n term t, the exponent with 0, we get 1. Okay, that's obvious. Therefore, we get this. So this is the general solution for this, but you can simplify further. So after this, you just apply the normal factorization method that will be covering in other chapters. So bye for now.